Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 459, count number of Trapezoids 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. First of all, I want you to solve Q2, right? I mean, there's no way around it. That is a prerequisite in understanding. And if you're not able to solve it, that's okay. I have a video for Q2, right? So definitely look for it. It's just count number of Trapezoids 1. It's either in the comments or if you search for count number of Trapezoids, you should probably see the other video that I wrote, that I have, right? It's just, it's just about showing the parallel parts of it, right? And there's really no way about it. Yeah, if you don't understand that part, this one would just be hard for you. I mean, it's not a strict necessary, like this is I wouldn't say like it's a prerequisite, but it is a, like if you don't get that one, it's hard for me to imagine you getting this one. But in any case, right? So the idea though is the same, and I'm going to explain it as an extension of Q2. So that's why just to be clear, it's 3:20 a.m. here in New York City. So my apologies if I'm not up or down or whatever for explaining everything again. In any case, yeah. The idea for Q2 is just that you have some points, and then you count the number of things all together on some axial parallel thing, right? For Q2, they are flat lines that goes through, and then you just have to find two of them, right? 2 points, 2 points on two different lines, right? And the way that you kind of go through it is just by sort of like an exclusion thing, because for these points, you want all the other points that are, let me take a different color. For those points, you want all the other points that are not the same level, right? And that's the idea. And for this one, if you do understand that though, then this one, while tricky, is not that bad in the beginning. In that, then now, keep in mind that for this problem, n is only 500. And that means that you can do 500 square type things, right? And why is that important? Because every 2 points can define a slope. And what that means is that, it's basically you just do all these things again, but rotated, right? And what I mean by that is I don't think my thing allows me to rotate by arbitrary percentage. So, oops. But the idea here is that now, instead of looking at it for axis parallel things, right? We do a hash on the same idea. Excuse me. Oh, how did that happen? And that was such a straight line. All right. Instead, now let's say you have 2 points. You have this point and you have this point, right? So then now we draw a line through them and get a slope, right? And this is basic geometry stuff, which I say that is basic geometry, but I'm really bad at it, so I'm not judging here. But it is, like things that at least I learned when I was very young, but as a result, I don't know, right? But it's the same idea. Is that okay? So there's this slope, right? You could say this is the slope, pretending that it is good enough. And then you have other lines that are kind of similar idea, right? You have 4 points, and then now let's just say they have all the same slope, right? If I had drawn them correctly. And then that's the same thing as before, right? So now you have this, you have this, you have this. So then now to get the count all these trapezoids that involve these points, then you just do the same math here and here, right? And again, the same idea we went over in Q2. So far so good, hopefully. And again, we'll go over the code part and how to implement this, but just want to give you the visualization and the idea to kind of play around with. The problem is that now we double count some stuff. And what I mean by that? What I mean by that is that now, because we have all these angles, let's just say a very simple thing, let's just say we have a diamond, right? If we have a diamond that looks like this, then now, well, first we draw a line this way, right? So then, yeah, that is no good. That is, that counts this twice. The same thing that we did in Q2. I mean, you could dedupe it, but it's the same thing that we had in Q2. In Q2, right? Because yeah, this is, we count it in the perspective of this line and then once more in this line. But then we also now double count it again with these lines, right? Because now we counted an additional time and additional time. So that was the thing that, well, I submitted a couple of times due to some silly mistakes. And then once I got a case, I was like, oh, wait, this is an issue. And I just kind of drew a square. You could draw a diamond. Maybe it's a little bit more illustrative for it. Also, there is an additional tricky thing about handling vertical and horizontal lines. We'll go over that in a sec. But yeah. And there are a couple of ways to kind of dedupe, if you will. I think actually I saw Alex mentioned one on my Discord, which is that now, actually, let me change the color. Do that. Now, for every 2 points, let's say this one. Okay, it's not a mutual. Let's say this one and this one. They define a middle point, right? So to count the number of parallelograms, you take every 2 points as a middle point, and then now any other 2 points where their midpoints are the same will now be a parallelogram, right? So so it's either here. You can imagine a longer one that goes like here. I mean, I'm not drawing it over it so you can see it, but you get the idea, right? Because as long as the midpoint is the same, then it forms a parallelogram. And you could, I'm not going to do the proof here, you could kind of see it. Yeah, the way that I did it was actually a little bit different because I didn't think of points like this. The way that I did it with my code is actually, let me choose another color. It's actually given these 2 points. I hash the distance between them, right? And if I hash the distance between them, that means that if I go this line and this line, if the other lines have the same, we just count the number of things that have the same distance. If they're the same distance, then yeah, then it's a parallelogram because no matter where it is, if they have the same slope, then it goes either here, and they're always going to be parallel because they have the same length, right? And that's the idea for this one. Yeah, and that's it. I had another issue with positions and fractions, but that's basically the idea. And the parallelogram thing is really, at least for me, really tricky. It took me a long time to come up with. And you can see the live version in the video if you want. I did get this one at the end very closely. And this is also, I just want to point out that this is why Q4s are sometimes so tricky, right? I mean, they're hard enough by itself, but if you just kind of look at this, and let's say my Q3 took an extra 4 minutes, right? 15 minutes instead of 11 minutes, no big deal. But that means that I'm not solving Q4, right? Sometimes it's as simple as that. So it feels very binary, and that's why you have to give yourself as much time as possible. And that means sometimes working on speed on the easier problems, right? In any case, yeah, so this is my code. This is in concept very similar to Q2. The thing that I have is well, I saw it, but it doesn't, in theory, it doesn't matter that much. But I have 2 things to help me. I have F. Basically, I have F of slope of, I call it the y-intercept. And basically, this just gives me the points that makes this, and the uniqueness, the dimension, if you will. It's going to be the slope. The slope is just a slope. So, you can think of it as just solving each slope once. And then y is, because we want a representative, if you draw any line, right, and there are like a lot of points, well, how do you define that line? And there are many ways to do it. You could do x-intercept as well. Maybe there are other ways to kind of muck with it. But the way that I settled on is the y-intercept, right? Because you have a line, a slope, which is a line. I just mark where it intercepts the y-axis, so that, like every point in that line is defined by that slope. And that's basically it for F. And then P is for parallelogram. Maybe I'll go over it. It's the same idea as P, Y. These 2 things are the same as before, but I added a thing called D, which is the distance. So it just has an extra thing that called D is equal to distance between two points that forms a line, right, or a side. And that's it. Yeah. and we'll go over it really quickly, for sure. Yeah. And the reason why we have set here is just so that, yeah, it's just so that because you can imagine like if the three collinear points like exactly the same, then you don't want it to show up 3 choose 2 times, which is 6, right? Well, it's 3 no 3 choose 2 is 3, but you only want it to show, well, okay, that's a bad example, but let's say you have 5 points, then you want to show up 5 points so that you could do the math later instead of having 5 choose 2, which is 10 different things in your thing, right? And then have to work out how to dedupe them or something. But yeah, I don't know. Maybe this part isn't. Maybe you could math it out, but I didn't want to spend time on it, at least without needing to, right? Premature optimization. But yeah, so then now this is what we said. But for I(n), for j is I plus 1n. So then you have ax, bx. You have the 2 points. We have the dx, dy, and then we have the d2 for the distance. I say d2 because this is d squared, right? So we don't have to calculate the square root for more complicated math. We have the G for GCD, right? And the reason why I have a GCD is just so that for the slope, this is so in a way it is normalized, right? And because we sort, because we sort the points, dx will always be positive or 0 or non-negative, I suppose. And dy can be anything, but so this after we do it by the greatest common denominator or factor, this is, you can also think about it as a fraction, right? But I kind of, yeah, this you can think about it as a fraction. So slope is dy over dx. So then we kind of divide out the common, the lowest, the greatest common factor, so that you have like a what's it called, reduced form, is it? I don't remember it's elementary school. I don't remember all the terms from elementary school, ironically, but you get the idea. So this is the slope. I make a special case for vertical line and horizontal line. I always forget which one's which, but it doesn't matter anyway, right? Because the slope key just has to be the same and consistent for all the slopes that you're trying to group together. That's the biggest thing. So I just wrote 0 and 1 just to kind of, but yeah, one of them is horizontal line, one of them is vertical line, and this is the same idea, right? Except for that, and here for that slope, and this is also we choose the y-intercept as the thing that defines a slope or a line tied to that slope. So here we just need something that defines that thing, so that everything on the same horizontal line or vertical line, I think I swapped them already, will hash to the same object, right? And so because dx is 0, ax is equal to bx, so I just take ax, and then ay and by are the 2 unique values, and then put them together. And here for the parallelogram part, we just keep track of the line, right? I think this case, actually, this could be a counter, because the way that we construct for for j, this should not have a dupe, unlike this thing. But I don't know. I think it was better. I was saying this up so I could debug it, and we needed to optimize we can. But keep in mind that at most we have n square number of points, so it's 500 square. A quarter of a million. I'm not worried about it. In theory, and the same thing for I think this is horizontal and this is vertical, but the same idea here. But maybe the part I should have gone over is the normal case. Yeah, and the normal case, this part is, I need to figure out a cleaner way to write this, but I just kind of work it out, right? So this is mx plus a is equal to y. This is relatively straightforward. So you could think of this as just solving this formula, and the value is actually probably like this, right? Or you could say maybe y is equal to this, right? But to get the y-intercept, but the thing is that yeah, I didn't want to deal with precision errors, anything like that. So and given that this is an integer and this is an integer, so I just wrote the top and the bottom, and then I just kind of manually normalize it, right? That's it, right? So this is just normalization of the y-intercept, or what I call the y-intercept. So even though in different places we use it differently, right? Yeah, so then now that means that the core idea is that anything in the same slope with the same y-intercept maps to the same line, and we just want to kind of group them together. And that's, as long as you keep that principle, keep that invariant, everything is pretty okay. And yeah, so then for f, we keep track here, we add a, b, and b, and this is the same thing, right? A, remember, is the I guess this a, which is which it's a tuple representing a fraction, right? It's the top and bottom, and we already deduped, and this is just to get the signs right, so that you don't have, like, if one of them is negative, you know, they're different. It's just normalizing it and removing the lowest or greatest common factor, and that's basically the setup. And then here, this is way similar to Q2, so definitely, like I said, Q2. Without the parallelogram part, this part is the same as Q2, kind of. Of course, it's a little bit different because now you're dealing with, you know, all these other lines. And yeah, and that's it, right? This is very much similar to Q2, so I don't know how to describe it differently, but it's just for the number of points. If we have 2 points of a given line, then we could choose 2 of them, and then we can just, yeah, and then now it is that number times all the other lines that are not on the same line as the current line. So that's the total, and that double counts, right? And that's fine. And then p total is just the parallelogram total, and this is the way that we have it here. This is actually, and I also have an early termination. This just means that it has 0 contribution to the answer, because, well, it's either we have 0 or the length is 1, so that means that you only have one side, so the answer is also 0. Like this would be 0, and so you skip kind of doing this part. But the parallelogram part is just, okay, if you have 2 points, yeah, you just kind of add the d squared distance. You have the total that's within that distance, right? And then you kind of subtract out all the other ones. And this is the idea. I'm not going to go into it that deeply because this is exactly the same idea as here. So definitely, maybe I'm a little bit lazy in explaining it, but I feel like if you don't understand it fully, try to work it out yourself, in the sense that it is exactly the same idea, right? Except for, I mean, it's a little bit different, but work it out. Is it an exercise for you at home? And that's it. And that's it. I mean, I say it like it's easy, but of course it took me an hour and 10 minutes and to the last minute almost. So yeah, in the parallelogram part, you do double count the double count. I mean, we kind of drew it out, right? You count the first, you count everything 4 times, because you have, for each side, you have up, bottom, and left, and then also the other one, right? So then you just do it by 4 to kind of adjust for that double counting, and that's it. Yeah. What's the complexity here? I mean, I do a little bit of sorting in the beginning, but honestly, otherwise everything is linear. The sorting makes the code a little bit cleaner, in that I don't have to worry about, like I said, dx is non-negative. That's the only thing the sorting does. But everything also is linear, so yeah. So if you don't do the sorting, it's a little bit messier, but it's still fine, and it's also linear. Oh, I lied. It is obviously not linear. Sorry. I mean, this is n log n, but this is obviously n squared. Sorry, it's 4 a.m. So my apologies. I'm thinking of some, but it is n squared but it is linear after you have. But that's just, I don't know. That's a crappy way of saying it. But what I meant is that given every side, it is linear in that. But yeah. But whatever. The actual way to say it is n squared. My fault. My apologies. So this is n log n, doesn't cost you anything anymore. This is n squared, right? And for everything, and yeah. and there are at least, oh sorry, at most n squared slopes, right? So this is also n squared, and everything follows as a result, right? Yeah. But yeah, the number of intercepts should not be that much. So yeah, and that's it. That's all I have for this one. Let me know what you think, and yeah, you could watch me solve it during the. Let me actually show the code real quick. With sorting, setting the slope, horizontal, vertical, setting the y-intercept. Well, this is setting the y-intercept, if you will, and then this is just adding the uniqueness, and then yeah, and then that's it, right? That's it. That's all I have for this one. Let me know what you think. Sorry, it's late. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Easy time now, but nothing too hard, to be frank. Just a lot. I have to modify sig tree. All right, Q4 points. Coordinates. Number of unique trapezoids. Segment from what's a unique trapezoid? Oh, just like there's no weird things, right? So the parallel lines part is kind of interesting, I suppose. 2 distinct ways to pick 4 points. So it's these 2. Okay. So it's not axis aligned. I suppose that's the thing. There's only 500. So let's give it a think. 500 n square log n. So for every 2 numbers, we have a hash. That's it, right? As long as they're not exact. Okay, so how do you define them? What is the unique? Like the x-intercept, maybe? Maybe 2 numbers you give in the slope, right? And I think that's basically how you want to do it. Every 2 points you do slope and you hash on the slope, and then basically it's the same algorithm as we had for Q1 or Q2, I forget. But the tricky thing is horizontal or vertical lines, right? Vertical line is 1. No, you just do dx dy and then gcd it, so you don't have to worry about that part. But then the other thing is, how do you calculate the unique, or whether they belong on the same horizontal? And the idea then is, does the area have to be greater than 0? I suppose so, right? Because if they're all on the line, then, you know, they don't actually say, which is actually kind of, because I know it's a degenerate trapezoid, but you could argue that both way is like a rather problem, right? So it's a little bit weird. But anyway, okay, so then, and that's fine, because all these lines with a different slope will be good. We just kind of need to find, okay. So we put a set on each of those, on each slope, but on each slope we have to, I mean, in theory, I think you just want the x-intercept or y-intercept. Well, I guess one of them is trickier if it's a vertical line to horizontal line. How do you define by, like, if 2 things have the same slope, the way that we did it by looking at, I guess, the y-intercept for horizontal lines, I forget, or x-intercept, I forget which one. No, it's the y-intercept, right? Yeah, for the last one for horizontal lines. But how do we want to do it? in a clean way without fractions. Oh, I guess it doesn't matter. You don't need fractions for the y-intercept because you can just round it. Because by definition, if they have the same slope, is that true? Yeah, because they have the same slope and different x, y, and they're all integers, then it'll round down to the same one. Okay. Okay, that's fair. And it's only 1,000 anyway. 1,000, negative 1,000. Okay. Yeah. Okay. Okay. Yeah. Yeah, okay. Yeah. Sorry, I'm so it shouldn't be that bad. Okay, yeah. So then now we get let's just say slope is equal to dy dx. Let's y ax ay is equal to points I, bx by is equal to points of j. I forget if slope matter. Slope doesn't matter which one is go, right? Because it's just dx dy, right? So dx is equal to bx minus ax. Well, don't get that wrong though. Y, so then slope is this, but we want to GCD it. I've handled like negative and stuff like that, so that's why I'm just thinking through is this easier. If yeah, I mean, then just it is very awkward, but yeah, if we want dx to be negative, so if dx is greater than 0 and dy is less than 0, then in that case we just swap the signs. Cannot type. And then that should be okay. And then now slope. Okay, so that's the slope. What is the intercept, right? Was it mx minus a or something? So we just plug it in. So this is the formula or something, right? So then now with then minus a on both sides. What? Am I confusing things? What is y to y-intercept? I forget. Honestly, it's been too long. It's been too long. I forget which way it goes. Okay, but they just I don't know. They just try it out. I forget. Okay, so that's a slope in whatever form, but then now we want it in. Okay, so you have dy. I'm trying to keep it integer. That's why I'm trying to figure out how to times x plus a is equal to. Okay, so let's just say ax, ay, maybe. It's either that or this one. I always forget. But then now we times dx on everything. Right? Wait, did I do that right? Yeah, okay. Times dx on everything, and then now we're solving for a, so we just subtract this, maybe. And then now we divide this back out, maybe a little bit awkward. Is A doing the sub? Or is Y doing the sub? Man, why am I so bad at this? Let's just print A for if this is the case, and then yeah, my geometry is up there, but people are laughing at me, and probably reasonable. But okay, let's just times x plus so ax plus ay, maybe this now. So print this, and let's just say ax ay bx by. May give me whoops. May give me a divided by 0 thing, but maybe that's fine because it just gives me enough, right? So, okay, negative 3, 2. I need to write it out. Negative 3. I need to draw it out because I am so bad. Actually, maybe it's this is on here. Negative 3, 2 is the one on the left. 3, 0 is this one that's not highlighted, and the y-intercept should be, according to this graph, like 1 point something, right? Is this 1 point something? No, it's 1.0. It's A. Doesn't feel right. Actually, no, that is 1.0. Okay, so that means that this is, yeah, this thing is right. 3 point. Okay, so this formula is right. Maybe let's try see another one. I'm not practicing enough and having to prove stuff like this is what kills a lot of your time and goals. So I guess people just cheat and Google maybe. Okay, negative 3, 2 and 2, 3. That's this one. That's the one that is drawn. 2, 3, and it crosses at 2.5, 2.6 maybe. Yeah. Okay. So okay. So this is the y-intercept. Okay. As long as dx is not equal to 0. Okay. So maybe we. Dx is equal to 0. What's dx is equal to 0? Is it vertical? I can't tell what's vertical and what's horizontal. I'm just bad. Okay, so 3, 0, so 3, 0, 3, 2. Okay, so it's vertical. So I think for now I can just skip it. We can skip this. Otherwise, we have this, and we can actually just take the 4 of it. I want to say because everything is uniquely, because with the same slope, the offset can only be in increments. So I think this should be fine. That's the key anyway. Yeah, okay, fine, right? So then now this is the x-intercept. So then we can say f of a and kind of the slope, but dy dx, I suppose. No, I mean yes, but also okay. I want to write it in slope of a append ax ay, and then also bx by, right? Or I guess it's not an append. It should be an add to a set. So okay, yeah. So then now what we want is f dot. For every slope, we have a set. Oop. So something like that, right? Run it real quick. Okay, it doesn't crash, which is what I wanted. Can even print it out for funsies. Okay, it's very crazy looking, but should be fine. Yeah, this is the x-intercept, right? So you 2, 3, okay. And then now we have to handle. Remember vertical. I feel like I keep on forgetting things, but okay. Okay, we can just write maybe f of. So then now we want the x-intercept instead. So then here maybe we write dx is 0, so that's already kind of awkward with the slope. So then we just write dy, and then we use the x-intercept. So vertical, oh, is it x? Yeah, x-intercept, which is just dx is 0, so you can use either one of them. Add the reason why I want to this thing is because it'll handle the code dependent points. Okay, I guess I might as well do that here too, because otherwise I was thinking about just using a counter, but yeah, maybe that makes more sense actually. Ax is equal to bx, so then this should be good. Okay, and now for s slope in f dot keys, we don't actually care about it, right? So we just do f dot slope or f sub slope. I'm gonna say for each of these, so we did the same thing. Okay, I mean, we kind of did most of the logic, and I could reprove the logic, but honestly I just want to double check. We just want this part. I just want too many things in my head already. So we have t is equal to 0, and then yeah, we get the total. So then we go for key in, so that's a unique identifier, right? And then we have f of slope of key, and then we care about only the length of this. So if length of this is greater than 2 or greater than equal to 2, then we all right, so then now maybe we have an array r dot append combination of maybe only need 2 of them, and then yeah, that's it, right? Oh no, that's not it. I mean, the same, we did it already, Larry. We did it already. Just copy and paste if you are unconfident. Okay, let's double check. I think that's right, except for that I put it here instead, because I have to always mess things up. Okay, so then now we have the total, right? And then yeah, and then it's just for z and r, we have an actual total. Actual total could be outside. Actually, we already handled this, maybe ideally, maybe not, but total we added by, do we have mod? There's no mod. I guess there's only 500, so maybe not. 500 to the 4th is maybe not. But yeah, but you go to z minus t, or z times z minus t, and then we just return total. And I think maybe we're done. We have 2, 1. Come on, baby. No. Oh. Yeah, I mean, I made the same mistake last time. I don't know how that keep happening. Like on Q2 or whatever it was. -2 and -2 is not so great. T. Oh, T minus Z. Oops. Okay, slightly better. 2 and 1. 1 is a little bit sadder, but why is that? Dong dong dong. How do I get 2 when this? Alright, let's see. Print slope, f of slope. Is that my weird case? No, slope is fine. Slope, f of slope. Oh no, there is a vertical line one. Did I mess this up though? Because this should be 0, right? So if oh, t is 0. Maybe there's a lot of weird things to it. I don't know. 0, 1. The 2 points, 2 points. So that's it's the same thing. I already did this, Larry. In Q1 we had divided by 2, and I totally forgot again. Wait, but I think one of them is actually 2 though. So okay, so this part we definitely needed to divide by 2. So this one is under counting. I think this one doesn't make sense to be anything else. So this one we're undercounting. Why am I undercounting? Oh, vertical lines again, maybe. Yeah, vertical lines is yeah, vertical lines I don't handle correctly because the slope is not 1. The slope is not 1. It's not dy. That doesn't make sense. Ax, because dx is 0. Yeah, ax makes sense, but dy doesn't make sense. It should be just 0, say. Okay. We just don't handle the vertical lines correctly. Okay, yeah, now we do, because they merge correctly for all vertical lines. Do I have a print statement? I do. That's why I'm like trying to find it. Okay. Okay. Now it's time to YOLO submit. Hopefully no weird wrong answers. I wouldn't be surprised. But I don't use any fractions though, so or any explicit fractions. Maybe the negative numbers is kind of awkward for sure. Because I took up this thing. So okay, fine. Why? Tell me why. But we're close. I feel like we're close. This is maybe we just don't do things correctly. Yeah, because if dx is greater than 0 and dy is less than 0, then dx should be, yeah, this is the 0 case is weird. No, but we don't, for the 0 case. Also, why do we okay, fine, let's just print dx dy. That's a little bit more natural, even though its slope is technically the other way. Okay, so negative, so this is the only case. But if dx is 0, we don't use dy anyway. So okay, but what if it's horizontal? Maybe this one is the wrong issue, because then the slope is -1. Dx is -1. Dy is, the slope is going to be because the slope is different across, because it could be 1, 0, even though all the slopes are 0. Okay, I see. That's easy fix. 0 is such a weird case. Maybe I should have handled it anyway. Let's just, what are you doing? Let's just handle it in a different way. And let's just do. As long as they're unique keys, I don't think it matters. Okay, should be 4. Okay, we're getting 4. I almost thought I forgot to do continue. Oh, we overcount. Okay, so did I left the print statement in there? I did leave the print statement. Oh no, I didn't. Okay, that's good. I worried about that. I mean, I guess it wouldn't have mattered for this one, but still. Why? There are a lot of like collinear points, so maybe that's why. I have 11, even though it seems like we have a lot of points on the -89 xy, yeah, -89, and then 2 points on 11, so it's gonna be 2. It should be something like this, but ay 0. Let's see. Yeah, a lot of this one's a little bit awkward, but should be able to fix it. Still wish I didn't get 2 wrong answers though. That's not great, because I feel like we mostly had this, so it's not great, right? So yeah, this is on the 1. On 89 we have 5 points. Is that right? I guess so. I didn't really count. I thought there was only 4, but yeah, there's clearly 5. So 5 points. So 11, right? 1, and then this other slope. Oh. No, there's only 2. So that's fine with that one. No, that has also has 2 points, so that doesn't do anything. 5033 doesn't do anything. Wait, no, this is the one that does something. 5033 is the one where there is two things, and this creates the extra one. Why is it wrong though? Am I wrong? I think that's the one that costs the extra thingy. There's actually a lot of print, but 5033. I mean, it's hard to argue with this one. I don't like just looking at the math. Am I off by some funky number? Okay, so these are the points. Dx is 88. No, 66, right? And the other is 100. So 60 over 100 or something. Plus 66 plus 100, right? And here is plus 66 plus 100. So why is this not a parallelogram? Or a trapezoid, rather? Actually, now I'm confused. So, am I misunderstanding the problem? Did I? Or are these... No, I was going to say maybe these overlap with the other ones, but that doesn't make sense in the slope sense. Or maybe, like, what if we have a square? Would a square be double counted? Because you have a parallelogram. That's why. I don't handle the parallelogram. Huh. Yeah, because these two form a top edge, so now it's a parallelogram. I see. How do I handle parallelograms without just deduping it in a weird way? Okay, so now given... Wow. How many people got this? Well, okay, there's a lot of cheaters. But I thought I was close, but now I'm not so certain with the deduping because of the parallelograms. Otherwise, this would... Okay, how do we figure out parallelograms? Inclusion, exclusion? How... I mean, that's the only way that I can think, but how? Inclusion, exclusion. How do I think, or how do I? N cube is too slow, right? Yeah. Wow, parallelograms. It's a word I haven't even used for years, maybe. I don't know. When's the last time you say parallelogram? And now on this video, I've said it like 5 times, possibly more. Parallelograms. Okay, huh. I see. How do I intersect these in a good way? I thought I was done, honestly. About 45 minutes to go. The other one was a silly mistake, but this one, now I don't know. And it so happens that one of the side is horizontal, but it doesn't even have to be, right? You could just have squares, for example. And then that would be a very obvious case. How do I dedupe parallelograms and or just count parallelograms? Then I can subtract them out. Huh. I mean, okay, so this has, I don't even know. Okay, so given 2 points, if how do you calculate I mean that's what, okay. I mean I guess you can do it because you calculate the perpendicular of the thing and then, but is that even doable? So for every 2 points, you get the slope of the line, and then you get the other slope, but it has to intersect. So you could calculate the y. Wow, that's hard though. 45 minutes we could do it, but so for every 2 lines, I have to draw it out. What am I doing? Where's my notebook? No. So for every 2 points, these 2 points are part of a parallelogram. If there's a, you calculate the y-intercept with some point, and then on that line, you go distance from. Oh man, I mean, but that's still n cubed though. I feel like there's no easy way to kind of. Parallelogram. How do I calculate? Wow. I'm not gonna lie. I just didn't think through it fully enough. A lot of people got it though. I mean, okay, a lot of people are cheating, but still. What are my parallelogram algorithms? So you could give a slope and a distance, right? But that means that if ax, ay, we don't even count it, but here we want slope, intercept, parallelogram. I feel like I could get it. Okay. I think we just have to keep track of the length, the distance, right? Of these 2 lines. And then magic. The length, and then for all the other ones we want to. Okay, how much time do we have left? 40 minutes. Okay, parallelogram. Intercept P. Okay, okay. This is so hard. Oh no, annoying anyway. Is it still set? No. Maybe. What do I want to write? I mean, this is just to keep track for uniqueness. So then now we want same-ish thing maybe. Does that even make sense? No, is it? No. No, not like this. D2 should define, but this is awkward because I don't like to do it this way. In the sense that, let's sort points. Should have done it. That would keep it so that AX is always, yeah, so then that actually should have done that earlier, because then now DX should always be positive, right? So, yeah. 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 Maybe. Run it real quick. I think this is still right? 2, 1, I think that one was 4 because there was 2 and 11. Okay. I mean, right as it was before. Sorting makes it so that dx is always positive, dy can be negative or whatever, but so then everything is on. Okay, so that does the same thing we wanted to do anyway. They cannot both. Well, dx has to be positive or 0. Okay, and then now we want to write something like this. Someone like this, right? Run it real quick, no crash, pretty good. Okay, and then now we've tried to find the parallelograms here. Okay, these are whatever. Let's just ignore those for now. And now for parallelograms for K and F slope. What is K again? K is A, so it's just for every intercept, and then we get the combination. Okay, if this is, we still want this, and we want. Okay, and then yeah, I mean by definition it would have anyway, but because okay, let's just keep it straight. So P slope of the unique intercept, doesn't have to be intercept, but it could be an intercept. And then now for D2 in this thing, we have so then now we want to sum up the, do we want to sum up? No, I have to choose one of these. So it is sum up. No, I mean, yes, because sum up. Okay, fine. So then now we want to sum up so for a given slope. Okay, for a given slope, we want to sum up the distance for, okay, yeah. So D, we just add this, the count of it. I think it's fine, because that's the number of lines with that distance. Or whoops, D of D2 is the distance for a given slope. Okay, that's fine. And then we just do another loop. I know that we double count, but Okay, so then d2. Oh, we also want to need a d total maybe. Also, this shouldn't need to be a set, but because of the way we did it, this probably could be just be a +1, so we don't need the set. But for now, I think this is a little bit just consistent. 34 minutes. Well, okay, assuming this is right. Okay, so then it is just we want to subtract out for the slope and k. We want to subtract out this with all the other possible ones of the same distance to calculate for the parallelogram, right? So maybe p total is equal to 0. So then p total we added by dt times dt minus this, maybe. Yeah, let's just print out this p total real quick. I think this is also double counted, but we'll see. Okay, well, this should give me a non-zero response, so that's not great, right? Okay, we have the slope, the intercept, and then the distance, 914. Okay, I don't know which one. I mean, it's just so hard to read. How do I make this lower? I don't know. Where's my code? It's very weird. Okay, fine. Still don't know how to make this lower. I don't know what happened here. This Leetcode makes me scroll random things instead of like just putting it out in a line wrap kind of way. Kind of sometimes prefer that. Just having 0 element is actually very wonky. Oh, I see. What the this code is so weird. This UI is stupid. Like I don't know what's going on, but maybe it's fine for now. I see. The reason is because I do this here, so I have to keep track of that too. But okay, what am I doing? Okay, what is, okay, fine. So then now slope is technically 0, but the a is a little bit awkward. What is a? I guess we just kind of use ax intercept, fine. 2 dot add, I guess this is fine. Sorry, I had to take a pause to kind of mentally collect myself, but I guess this is at least consistent with what we have, so maybe that should be fine. I don't like this UI though, it's just really confusing me. And unfortunately it's still not working. And I don't even, this is so bad. Like it's just not expected. But anyway, okay. Why is that? DT maybe? Let's see, does DT return anything? I think so. What am I printing? Hmm. Yeah. I feel like we're close, but not close enough for me to be comfortable. Okay. So 11 dt minus dt. How do I debug this? Well, let's just actually write a better case. Maybe that's fine, but maybe we just want to square. So what answer would I don't even know where the one button is because it's in another screen for some reason. Okay. So here our answer is 2, which is actually, I mean, it's incorrect, but in a good way, because then allow us to kind of use that as an audit. Because it's a square, it double counts. Right? Okay. dt is 2. Actually, let me just print out p now, because maybe that's slightly easier to read than some crazy mess. Maybe not. I can't even scroll to the right easily, because Leetcode, makes the scrolling here. So then now if I scroll up to here, I cannot scroll. Thanks, Leetcode. Okay, this is actually surprisingly easier to read. Okay, so 0, 0, 0, 1, 0, 1. What is it is not easy to read still, because everything is zeros and ones. But okay, so you have this line and you have this line on different intercepts, or I call it intercepts, but in this case it's not, with a distance of 1 and 1. Right, so that's actually kind of what we want. So then why is it not, so dt is going to be 2. So then what, dt minus d1, oh, is it this, actually? D, oh, whoops, I forget. I was like, where's the, okay, still not great, but okay. Why? Okay, let's see. Print. I think this is too much, but okay, fine. So also I'm sweating here, which doesn't help. Okay, so you have a set of 1. Am I not doing this right? This loop is not right. I just kind of wrote it this way because I'm lazy. But is this loop wrong? This loop is wrong. dt doesn't make sense. This is the number of things of this distance, so there's this distance minus dt, but it's not dt. Okay, this formula doesn't really make sense. It should be this times d of d2 minus this. What am I writing? I think I just was putting random things together. But yeah, now you finally see something in the parallelogram. Okay, and it should be double counted because, yeah. Okay. So it's returning 4, which is double counting the double counting maybe. So maybe that's not great. Is that how? I just want to double check before I make sure that this is always a multiple of 4. Now this is a 2 here and 22 here, so it's definitely not that. Why am I getting? it's a step in the right direction, but why am I getting 4 parallelograms? 1 line, 1 line, so then it just gets... Okay, this way, okay. dt is equal to 2, dt is equal to 1. Well, we don't use dt. dt doesn't... I thought I did, but I was wrong. So... maybe. Do I not? Okay. Maybe I won't solve this one. I should be close, but okay. So 2 minus 1. So this is going to be 2 minus 1, maybe. So it's going to be 1 and then increments twice. So that's why it's 2, and this is 2 again. What is d2? The distance is 1, okay, but so once on the 0 intercept is a line, on the 1 intercept is also a line. I mean, I think this is fine, but why are we doing it twice? What does this represent? I guess you could print that actually. That's why you have this ridiculously unnecessary. Okay, so you have this line and it matches with this line. Is that right? Yeah, they're unique, and there's one. This one with this one is also... Why is it 2? This is 1 times 1, so that's 2. Okay, actually, I guess that makes sense. This double counts. Okay. So there is like double counting, which I'm trying to wrap my mind around for a second. So this... Oh, because it's a square. So, okay, so if it's a rectangle, it only double counts once, presumably. So we just say... No, it still double counts twice. Is it a rectangle or a square situation? Why is this case? Okay. Distance 11. D2 is 1. D of D2 is 11. Is this right? Is there like one more thing that I'm forgetting? D2 is the distance. Why is this distance is way more than 11? What am I doing wrong? Right? This distance should be... Oh no, it's D2. D2 should still not be 1. K is the intercept, D2 is not 1. So maybe that's why it's wrong. D2. Why? Huh? Am I just printing weird things? D2. Huh? This is the should be 100 square. This is 2 square. This is, I mean, this is definitely not a good reason. Why are they mapping to the same bucket? Am I printing the right thing? I should be printing the right thing. P slope is right. Is slope right? Slope should be right. K is the intercept. Okay. K is the intercept. Okay. D2 is 1. Why is D2 1? Tell me why. Huh? This is gonna be annoying. Why is this 1? Am I being dumb? I mean, yes, but still. Oh, that's not the real distance because it's normalized after this part. Okay. Okay. So then now d2 dy has to be here. Okay. 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 Now are we better? Not here. It's still the same issue. Well, I mean, that's fine because we were using unit square, so that makes sense. At least here, this is a little bit better in terms of like what we predict. That's actually pretty bad. There's still an issue with double counting, but I can't tell what this number is. This is 11, but I don't know what we're printing anymore because Leetcode is stupid. I blame it on Leetcode. Okay, 2, 2, 4, 2. Like, is it just double counting? I don't know. This is 4. Is it always multiple of 4? I don't know what all these. I cannot figure out what is it that Leetcode is actually printing because you see my craziness with the overlap, right? It's not just me. Okay, I don't need that anymore. Let's just. Okay, so it's 4. I want to say we double count twice. Is that reasonable? I think so, honestly. Get out the print. Because I could see it. I don't know if it's a reasonable thing, but I could see it. So let's YOLO. Also because we have 17 minutes left, so it's wrong. It's worth to paying the penalty to kind of get something real quick. Okay. Now I undercount, so maybe I don't know. I don't know anymore. But I mean, parallelogram is definitely the thing that I'm having an issue with. But this Leetcode is so bad. I guess that's what I wanted. But because I just don't know how to keep on having. But okay. I mean, I didn't want to assert because you know it's. Maybe I get lucky, but I was hoping that okay, so maybe that part is right still, but we're under with where can we have been doing this? So here we, is this for this one or this is for, there's no parallelogram? Is that right? Okay, yeah, there's no parallelogram. So then why am I wrong if there's no parallelogram? Is total odd? No. Okay, so I mean, at least we solved the parallelogram issue, but am I mean, so I thought maybe I overcounted this, but now I'm just, this is just wrong, or I'm just wrong somewhere, which is even worse. And how do I even debug this? All right. I mean, the answer is very painfully. Yeah, that's not super helpful. Double checking real quick because we did put D2 up here. Does that help? Or like, do I have to worry about anything here? I don't think so. I think the signs are okay. DX is positive. This is whatever. So I think D2 doesn't change or shouldn't change. D2. I mean, there's no parallelogram, Larry. That's not the issue. Then what is the issue, Larry? I don't know. That is a good question, Larry. This is the slope. Alright, well, It's 2 choose 2. Okay. I don't know. Print Z, T minus Z. I don't even know anymore. So there's just a lot of singular ones. Except for this 12 thing. And 21 of one thing. This is just so hard to debug, like without visualization and whatever. I don't even know how. Am I just handling vertical incorrectly? Maybe that's the only thing that I could maybe think of. I mean, it's not this because we're x intercept, y intercept, y dy is 0. So then you just match it with other dy's. 12 minutes to go. For a given slope. I mean, I do AXAY, but it's just dedupe, right? So, and AY is the same, so there's no other, by definition, AY is the same. And technically, in theory, actually, we can even just reduce this by AX or something, because the slope uniquely defines it. I think that's true, actually. So we can, I don't know about going in optimization, but it's just maybe slightly easier. We don't use it anyway. Yeah, but and this could have been a counter, but because we don't even use it, but it's fine. But I don't have no idea how to, like, unless I'm like, I don't use anything funky, right? Let's double check. I mean, dxdy, we don't have anything too funky. I imagine the GCD is right. And the slope doesn't matter for if one of them is 0. I don't know. I guess we don't need P total for this one, but okay, so this has 20. This is the one with the 21, I think. But I don't even know. Oh, I mean, a lot of these are just zeros, but I mean, this just reduced the number of print. Actually, like it is as optimization, but still don't know how that helps, to be frank. What does this 142 mean? Did I print out other stuff somewhere? Oh, that's the slope is 1, so that's all the vertical lines or whatever, or horizontal, I forget. The points are unique, right? Pairwise distinct. Yeah, and slope is dy dx, that's why it could be negative. Okay. Wait, if t is not equal to 0, then why do all these exist? Because t... Okay. But, okay, so now it's even shorter. So it's just, actually they're all vertical or horizontal. Huh. Is it possible that I missed one? I mean, I'm undercounting, so I was still thinking about parallelograms, honestly, but... This one has one. Okay, so there's this, so it's just one. There's no weirdness about it, I suppose. This one has 4, 5, 6, 7. So 7 choose 2. 7 choose 2. 7, 6, 40. So 21. What? Yeah, why is this 42 actually? Oh, because you count this one as well, so it double counts. Okay, fine. And then here, this is 4 choose 2 is 6. 6 times 6? No, 6 times these choose 2 times... So this is 1 plus 6, so this is 7, so this is 42, so 84. If I'm double counting. Wait, what? No. 4 choose 2 is 6. 6 times 7 is 42. And then here is the same, so 42, 42. And then here is so 84, 84, this has 12. So 84 plus 12 is 96. So that's, yeah, 140. So the math is right. How am I missing one? Why? Tell me why. Actually, I don't know. How am I missing one? And now I have 5 minutes. I guess I'm not getting it. I mean, I feel like I was close. The ideas I had pretty immediate, except for the parallelograms, which we saw. But this is not even parallelogram related. Right? Like, I think the math is pretty straightforward if it matches, but set, these are one-offs, right? So it doesn't do anything. Might not even be looking at the right problem anyway. And it's this. This is the vertical. No, that's from the previous problem. So what else can it be? This one. Like, is there a... No, it doesn't make sense. So this is the only thing that maybe... So this is slope for... I mean, that's the only thing that actually has 4 elements, so maybe there's something funky there. Maybe I'm wrong on the intercept. Okay, let's I guess the only thing that I didn't do is just use a fraction. Maybe that's like really bad, but can't even see what my results are actually. That's pretty bad at Leetcode. Just tell me what I return. Like, you put me the standard out but not my actual output. Like, how bad can you mess this thing up? So I guess I was wrong on my thingy. Huh. Oh yeah, maybe I was, because you can shift to the right, which has the same slope, not just okay, I am dumb. But alright, I don't know if this is quite right. We have 3 minutes, so I will have to YOLO submit. That was a dumb mistake actually. Like, you have fraction inaccuracies, which honestly very likely to give me a wrong answer. We have to figure out how to handle it. And the answer is more GCD, but we got it in the end. A little bit lucky. I don't think it. Some of it is because I do know a property in which, like, if this is less than 1,000, I think this always gives the right answer. But I may be wrong on that one just because it's been a while. But I was just operating off of really bad debug, and that took 15 minutes maybe. Yeah, because the other one's the parallelogram, but so maybe I should have done that to begin with, though. I don't know. I think I tried to be too clever with the floats, but still. But only off by 50. I mean, we could have done the same thing with what we had before, right? Which is top is equal to this, bottom is equal to this, and then G is equal to GCD top bottom, maybe absolute value of them, and then you could say yeah, A is equal to yeah, this is just a fraction. Basically, probably should actually just, is there fraction class in Python? I feel like people use imaginary numbers, but I don't think that's quite. I feel like maybe if I just have fractions, then is this standard? I mean, I'm about to run out of time, though. I solved anyway, but maybe if I just use fractions, that would be a little bit like not have to worry about it, because I keep on worrying about it. Like, I keep on doing it manually, and that's just like, maybe I could have done that. Does that work? Fraction is not defined. It seems like it says maybe that's not a standard. I mean, now the time ran out, but that's fine. Yeah, maybe I should have done it that way, actually. Maybe it's something that I should do in the future, actually. instead of like doing it myself. Maybe that is something to add to my toolkit. Though maybe it times out. Yeah, so maybe it times out with using fraction. So I needed to do something funky. I mean, I don't know if I would call double funky. I mean, double is also like just wonkier. I guess we can do something like this. Oops. Let's see. Right. I mean, time ran out anyway, but I want to. But then now we have to deal with like negative numbers and stuff like that, which is what we had before. So that, which is fine maybe. We have manual fractions. Let's keep it in the bottom, right? So top is going to 0. Yeah, and because bottom is dx and dx cannot be 0, so that should be fine, I think. Actually, I don't know why I thought, I mean, I know why I thought that, because I was thinking about shifting up, but I didn't think about shifting to the right or left for some reason, and that kind of very silly of me. I think I was just focused on getting the problem right. Yeah. Yeah. Yeah, I mean, we cleaned it up a little bit. It's a little bit awkward, and fractions class apparently is too slow, so we won't use that. This part I just want to show, but we did get the parallelogram part. Okay, now the submission didn't show up anymore. We did get the parallelogram a little bit late, but we still got it, so that's fine. But definitely a tricky problem. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.